Okay, so far, not too bad, right? Not too bad. Then we basically say, well, let's compute the average, right? So compute the sum divided by the price length. And clearly, the length field of this array is determined as soon as the array is created. Because the compiler looks up our list, sees, okay, seems like there's 4 doubles on this initialization list. We're using initialization list syntax, and therefore that's the appropriate size for the doubles array to be created. In addition to that, just a reminder that once created, Java arrays are fixed in size. They cannot be reduced in size, they cannot be expanded in size. If you run into a situation where suddenly you need a bigger container, your only option, if you chose array to be your container, is to create another array of a bigger size and then find a way to copy data from the older array to the newer array. By the way, uh, um, we also have options with arrays, that there are copy utility methods that are available in the arrays class, and we're going to cover that today. So what could be dangerous about this code? Is this code does this code look okay? For the most part, yes. The only little curious part here is this division by something. Uh, the danger of division is that division by 0 is not a good thing. Some people always assume that arrays are always non-zero length. But let's try this. What if I had a method that is public, static, and what it returns back is a double array, right? So the method that somehow creates an array, create array, right? A method that creates an array and takes integer size, or we can say array size, as a parameter. And here I'll do something. Here it doesn't like something about my coding. Public static double create array. Oh, it needs to return something. That's why it's unhappy. So what I'm going to do is that I'm going to say double array temp equals new double double array array size, and then say return temp. Okay. So in its own standpoint, create array seems to be a little impractical here because, well, I don't have to create a separate method to say create new double array of this size. I can just use this one single line and do it directly in my code elsewhere. However, this method could do something extra. It could do something else. It could have its own logic. It can have its own initialization of array. Perhaps it will initialize the array to a sequence of numbers 1, 2, 3, 4, 5, 6, 7, 8 for the entire array size. Or maybe generate prime numbers and populate array with prime numbers. So it's a legit idea to have a function which actually allocates an array. So maybe then I could, alternatively do something like this: double prices equal, and just call this thing create, right? Just call my method to create an array, and I can pass 4 as an array size. Now, again, just to be very clear, numbers such as 4 typically are they're called numeric literals in our code. When you write code like this, no one in the world can understand what for means. Well, yes, they know for is intended to indicate an array size when you call create array, but no one in the world understands why exactly 4. Why not 5 or 2 or 4 million? So in real code, we should kind of do something like this: static final int um, array size, um, maybe default array size, and uh, indicate what this is. Um, although naming something default array size still doesn't explain a lot of things, but arguably this is a much better style. Okay, just keep that in mind. By the way, final means, of course, that this integer that we're creating, the static integer inside this main app class, is constant. It means we initialize it and then it cannot change. So it's a constant value. Okay. So anyway, what if we did all this, and then of course, let's perhaps populate our array with some data, prices. We create an array with all zeros in it. So prices, say 2 equals uh, 0, 1 to 1195 as an example, right? And then something else. Prices 3 equals 995. And if we run this program now, save everything, run this program, it should print the average. Right? So it does, and it says the average is 5.475, right? Oh, you already know that we could use number format class to tweak the way the currency perhaps is formatted or whatever, and so we can make our further improvements. Any questions about this code so far? I would like to clarify one thing, which is, when I first was studying the subject of, structures in C, which are examples of objects in memory, I always was curious about the fact, how do you manage your code so that you pass references to your object from one part of the program to another. I would like to make it pretty clear that what happens in our example here, after we changed it from declaring an array directly in line to create to go and create a method that does the work. I'd like to clarify one thing. That what happens here is that, and my habit is that I always prefer to not just to look at the code, but part of understanding of that code is to kind of visualize what is happening. So my visualization is this: the main program is invoked, right? And it contains, of course, it's given its local scope with all local variables. This prices, PS, prices, right, is a reference to an array. What happens is that main calls create array method, which is another call, which gets its own local scope of variables, and it creates this temp, right? The temp array, which is an object reference, and as a result of executing new double, what happens is that we create this object. The object is created in memory and populated, and this temp keeps track of it, right? So the temp provides object reference to our array. Arrays in Java are objects. Period. That's the definition. What happens then that the create array returns, and it says that I will return an array of doubles back to you, right? So this should be interpreted as the return type of this method is an array of doubles. An array, as you know, is self-sufficient in terms of it keeps the field internally in this object right here. It knows its size. Each array in Java remembers its size, and you can ask any array, what is your size? And it remains unchangeable until array is destroyed. So what happens is that when we return, we pass back to the main function this array reference, which is then becomes prices in our main program after create array returns. So prices now points to the same object. And by the time we return, of course, all of this is gone, right? No longer exists anywhere.